So today we'll be looking at trigonometric ratios. Okay, we'll be looking at trigonometrical ratios. Alright, before we start, I would like us to do a revision. Trigonometric ratios involves right angle triangle, right angle triangle. Right angle triangle. So this is a right angle triangle, and here we have, let's label it A, B, C. So let's look at the sides of the triangle. Let's call here P, Q, and R. So we know this side, which is the longest side, from Pythagoras theorem. So we'll start with Pythagoras theorem. From Pythagoras theorem is associated with the sides of a right angle triangle. Okay? So with Pythagoras theorem, we know that the square of the longest side is equal to the sum of the squares of the other two sides. So remember this notation. We'll be using it to solve problems while we work on trig ratios. Alright? So always remember this side is called the hypotenuse, which is the longest side, is equal to the square of the hypotenuse is equal to the square of the other two sides, their sum, the sum of the squares of the other two sides. Alright? Now let's look at the basic trig ratios. So let's look at the basic trig ratios. Basic trig, I abbreviate trig, trigonometrical ratios. So we have three of them. So let's draw our right angle triangle again. So let's label it A, B, C. Let's also call it P, Q, and R. Alright. Now let's consider an angle. Let's call here theta. Now we remember that here is called the hypotenuse. Hypotenuse. I'll abbreviate that with HYP. So this longest side is called the hypotenuse. Now when we are considering this angle, the side opposite the angle is called opposite. So here it's called opposite. It's called opposite because it's opposite, the side is opposite the angle we are considering. Okay? Then this last side will be called adjacent. Now suppose it was this angle we are considering, then this is the side opposite this angle. So this side will become the opposite, while this side will become the adjacent. Okay? But in our figure on the board, we are considering this side, this angle here. So this angle is opposite to this side. So this side becomes opposite, while this other side becomes adjacent. I believe that is clear. If you have any questions, you can drop them at the comment section, okay? We'll look at them. Then, what we need to do next is to establish our trig ratio. We have a short form for remembering them. It's called SOHCAHTOA. I believe some of you must have heard of this word before. SOHCAHTOA. So the first basic trig ratio we'll look at is sine theta. So sine theta, we are considering this theta here, okay, is equal to, this sine is x. O here stands for opposite, H here stands for hypotenuse. So sine theta is opposite over hypotenuse. So which we can write in simple symbols as P over Q. P over Q. Okay? Alright. Now the second ratio, so this is the first ratio. When we are considering this angle, here is opposite, and here is adjacent, and here is hypotenuse. Hypotenuse is always opposite the right angle. Hypotenuse is always opposite the right angle. Now the next thing we will look at is the cosine. We write it cos theta. C here is cos theta. A here represents adjacent over H here also represents hypotenuse. Okay, and that is equal to, so our adjacent is represented as R, and our hypotenuse is represented as Q. Okay, and lastly we have the tan theta, which is represented by this T here. Tan theta is equal to, the O stands for opposite, which is here, opposite, and then the A stands for adjacent, ADJ, adjacent, and that's equals to P over R, P over R. Okay, so I want you to put these results down and put them at the back of your mind. But remember, I said again before we go further that opposite and adjacent always depends on the angle you are looking at in the right angle triangle. If suppose we are looking at this angle then the side opposite that angle, which is here, becomes opposite, and while this side will become adjacent. I'll take that again. If suppose we are looking at this angle here, because in this case we are looking at theta, this angle, the side opposite this angle is this, and that is why it's called opposite. And the side opposite this angle is called the opposite, while the other side will be called adjacent. Okay? But suppose we are looking at this angle here, then this side will be opposite it. And so here will be called opposite, while this other side will be called adjacent. But the longest side always remains as hypotenuse. It doesn't change. And it's always opposite the right angle. The hypotenuse is always opposite the right angle. So no matter the shape is tilted, also always note that the hypotenuse is always opposite the right angle. So we have established the three basic trig ratios, which are the sine, the cosine, and the tangent of angles. Okay, and we've been able to establish their relationship based on the right angle triangle and the angle we're also considering. All right, so we'll stop here and take the reciprocal of these trig ratios, and then from there we'll try a problem. Okay. So let's look at the reciprocal of basic trig ratios. So let's look at the reciprocal of basic trig ratios. There are also three. The first I want to look at is the secant of angles. We are still looking at the three angles. So the secant of angle is simply 1 over is the reciprocal of cos theta. So once you know your cos theta, you can get your secant. Okay? And then the next is the cosecant, and the cosec is just the inverse of sine theta. Okay? So remember these ratios. And then the last reciprocal is the cotangent. Cot is called the cotangent of theta, and that is just the inverse of tan theta. All right. So also put this established facts down. Put these established facts down. Put all these established facts down before we solve some problems. But before we do that, note. These are very important results. Note that tan theta is equals to sine theta over cos theta. It can also be equal to sec theta over sec theta. over cosec theta. Okay, so I don't have time to start proving these relationships, but they hold, they are true. Okay, you can as well test them with the facts we have on the board. They also note that cot theta, remember cot theta is just the inverse of tan, will be equal to cos theta over sine theta, that is the inverse of this. It can also be equal to the inverse of this, which is also cosec theta over sec theta. Alright, so let's see and try one basic example before we close the class today. Okay, before we close the class today, let's try one basic example. Given that sine theta is equal to 5 over 13 and theta is acute. So acute means the angle is less than 90 degrees. Alright, so we are asked to find Roman figure 1 cos theta, Roman figure 2 tan theta, Roman figure 3 sec theta, Roman figure 4 cosec theta, and Roman figure 5 cot theta. And now this is very easy to do from all we have been discussing. It's very easy to do. So let's solve this together. Solution. So first of all, we'll draw a right angle triangle. We'll draw a right angle triangle and then fix our angle theta anywhere. You can fix it either here or here. Okay? So if we fix it here, we know that here become opposite and here become hypotenuse, right? And here become adjacent. Right? Remember again, I'm emphasizing the side opposite the angle. See the angle we are considering. The side opposite it is called opposite. The side facing the right angle the side facing the right angle is called hypotenuse. See the side. Once you get your hypotenuse and your opposite, the last side becomes adjacent. Right? Okay. So we were given sine theta equals to 5 over 13. And then we remember that sine theta is, from the formula we established before now, that sine theta is opposite over hypotenuse from our saw cartois, So the saw sin theta is opposite over hypotenuse, right? So that is where it is now, opposite over hypotenuse. So the opposite is 5 and the hypotenuse is 13. So the opposite is 5, which is here, and the hypotenuse is 13, which is here. Are we good? I believe. If you have any questions, you can drop them in the comments. We will check and give you reply. Okay? Now the next thing you need to do is we'll try to get this last side. We know here. So our job is to get here. And we can simply do that by getting this angle and then working the mathematics, but then it's very easy when we use our Pythagoras theorem. Okay, Pythagoras theorem is straightforward. That's why I started by the revision of Pythagoras theorem. So for Pythagoras theorem, to use Pythagoras theorem, so from Pythagoras theorem, we know that this is the hypotenuse. The hypotenuse squared is equal to the opposite squared plus, let's call here x, the adjacent squared. Okay? So if we solve this, you have 169 is equal to 25 plus, this will give us, this is the s squared. So we take 25 here, so we have 169 minus 25 is equal to s squared. Okay? So our job now is to get the adjacent, and then we can start solving all these questions. So this minus this gives us 144, which is equal to s squared. All right? So we can take the square root. When we square root both sides, s is equal to the square root of 144, and that is equal to 12. So we see that the adjacent is 12. So we see that the adjacent is 12. So the adjacent is 12. So very easily we can now get our cos, tan, cosec, sec, and cot. So I'll do that above this solution here. So let's get our first question, which is cos theta. Remember we said cos theta is, remember your car. Remember your car, which is adjacent over hypotenuse. Adjacent over hypotenuse, okay? So we already know our adjacent. Our adjacent is 12. Our adjacent is 12. And our hypotenuse is 13. So we are done with this. So cos theta is 12 over 13. Very easy. The next thing we need to get is tan theta. So remember your TOA, soccer TOA. Your TOA is opposite and adjacent. So tan theta is opposite over adjacent, and that is equal to opposite is, our opposite is 5, you can see it here, 5 over our adjacent is 12, you have 12, and we are done. We are done with that. So it's quite easy and straightforward to solve. So the next thing is our sec. We know our sec theta, we already know from the formula established, is 1 over cos theta. So it's just the inverse of your cos, the inverse of your cos. So if we do the inverse of this, if you do the inverse of this, the denominator goes up and the numerator goes down. So that's what gives you the inverse. We are going to do the inverse of cos theta. So we have already cos theta here. See your cos theta here. So the inverse of cos theta, 13 goes up, 12 comes down. That gives you the inverse. And so we have this to be 13 over 12. It's as simple as that. It's as simple as what you have now. Very simple. So this gives us the inverse of cos, and that is sec theta. Just take the inverse of this. Okay? So the next one, which is Roman figure 4, is cosec theta, and that is equals to 1 over sine theta. So we already have sine theta from the question given to us. Sine theta is 5 over 13. 5 over 13. Okay. So the inverse of 5 over 13, 13 goes up and 5 goes down. And so that gives us 13 over 5. So this is the cosec theta. And lastly, we have Roman figure 5, tan theta. So tan theta is cot. Roman figure 5 is cot theta. Cot theta. And we know cot theta as 1 over tan theta, right? From the formula we have established. So what we need to do is just to take the inverse of tan. Look at our tan here. So we take the inverse, and that inverse is 12. So the denominator goes up and the numerator goes down, over 5. So these are the solutions to that to the question given to us. So remember, we use our right angle triangle, fix the sides based on what was given, and then get the top side using Pythagoras theorem, and then apply our basic formulas as we established already in the lectures, and then just fix your values based on what you have on your triangle, and then the solutions will just appear. So because of time, we'll stop here for today's live class. Hopefully in our next live class, maybe we'll look at it next Saturday, and we'll continue from where we have stopped. But in then, I want to encourage you to look for questions in your math textbooks and try some problems relating to what we have done today. So in our next class, we'll be looking at quadrants, and then we'll also look at standard angles, and then we'll look at complementary angles. All right. Maybe I should leave you with a question. I don't know. All right, I will post a question on Trig on our page, and then you can just try the question maybe by tomorrow. Okay. That will be all for today. Thanks for participating in today's live class, and I hope it has really been educative enough for you. All right. Hopefully, we'll see you next Saturday for another live class. But don't forget, we are dropping videos every now and then on our pages on Facebook, YouTube, and Instagram, and TikTok. So any platform you are, you can get videos. Just search for Jet Mathematics, or you search for my name, Milton Ebiwari John. You get these contents on the internet. Thank you very much. Thanks for participating. Bye.